Welcome back. Today we continue our series in TypeScript tutorials. In this series, we try to solve or try to answer interview questions that you might face in your TypeScript interviews. If you're new here, make sure to subscribe and hit the notification bell so you'll never miss a video. If you're not new and this is you're just you used to watch my channel, so I'm happy for you. I'm happy that my content you like my content, and welcome back for you. So let's start real quick. Today we have the question which is what are differences between generics and types? And here generics and types serve different purposes in TypeScript, and here are the key differences we'll try to talk about. First, we want to talk about type generality. Let's talk about the type generality. One. So in generics allow you to create flexible and reusable code components that can work with various data types. You can parameterize types, classes, functions, and interfaces with type variable. On the other hand, the types are used to create type aliases for specific often complex data structure. They do not provide the same level of flexibility for working with multiple types as generics. Let's just talk like function. Let's call it identity. Yeah. And right now here we are defining right now generics. Generics are being defined with this angle brackets, and we can use for example const result. Let's call it 1 will equals identity of string, or maybe identity, and we have maybe like 2 will be identity of number, and therefore this will not be right. Maybe we have this will be right. On the other hand, let's just try to create an interface. Let's create a type. Type will be a point, x number, and y will be number. And we can create a variable const, we'll call it origin, and it will have the type of a point, and it will excel. What was it? Okay, because it has no scope. And yeah, I guess it will be the same because it has no scope. It doesn't matter. Okay, and let's continue. I want to talk about the parameterization. So we'll talk about the parameterization. Generics allow you to parameterize functions, classes, and interfaces with type variable. For type variables, making them adaptable to different data types. On the other hand, type aliases are fixed and cannot be parameterized, or cannot be changed. Parameterized, they represent a specific shade of data. So for example, you can have a function, this function, for example, this function identity2, maybe it return the t anyway, and we can just make this the string, or maybe we can make number, we can make it a boolean, whatever we want. On the other hand, the type point, for example, if we have a type called point, you have x a number, it's not you cannot change it. It's just x should be number and y should be number, and every object that adapt this type should have these two and these only two variables, and should have an X should be a number and Y should be a number. The second thing I want to talk about is reusability. And here generics are promote code reusability because they allow you to write function classes or interfaces that work with wide range of types. However, types are useful for defining specific structure and may not be reusable for different data shapes. Sorry. For example, we have this T. We can reuse it with a string. We can use it with 0. We can use it with like a boolean result 3, and make it like boolean, and make it false. And as you can see here, it's flexible that we can use with different types. However, in the point, you can't do this one. In the interfaces, you can't change. It's only you can use it with the point. You can't, like, all the variables that will adopt this type should be forced to follow this structure and this contract. Maybe we talk closely about the type references, which will be the type references will be type interface. Sorry, generics provide strong type interface inference. Sorry, type inference, not type interfaces. Sorry, I'm not focusing today. So first we want to talk about type inference. So inference. Let me type it right, please. Yeah. Basically, generics provide strong type inference, often allowing TypeScript to infer the generic type based on usage. On the other hand, type alias do not provide the same level of type inference. You often need to explicitly specify types. So for example, let's look at this example again. So this is type is a number, this is type is this type is string, this type is number, and this type is a boolean. We have in the point here, we're using type explicit type, like it's exactly should be that exactly, you cannot change it. So these differences highlight the distinct purpose of generics and types. In TypeScript, generics are used for creating flexible and reusable code components that work with multiple data types, while types are used for defining specific data structure and type aliases. Depending on your code needs, you may choose to use one or both in your TypeScript projects. So that's it for this answer, for this question, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you guys in future problems.